Hey there everybody, welcome back. This is my second video now, and we're covering SAT Test 1, Section 3, Part 2, which is going to be problems 4, 5, and 6. Alright, so let's get started right away. Alright, now the question number 4 says, no two points on the graph have the same x-coordinate. Okay, which of the following graphs has the property stated above? Alright, so what we want to do here is we need to analyze these 5 answers or graphs here and see which one of them fits our original statement. So let's break down what our original statement means. No two points on the graph have the same x-coordinate. Alright, so let's just imagine a graph here. And we have our y-axis and we have our x-axis, right? So if it means a graph has no two points are the same, that'd mean if we had something like this point on the graph and this point on the graph, they both have the same x value, right? Let's say this is 3 and some y value, and then this is 3 and some other y value, right? Y prime. You see how they're both at the same, they're both at the same place, the same distance away from the origin on the x-axis, therefore they have the same x value. So we're looking for something that is not like this. So let's start looking at each graph we have. And I'll zoom in so we can get a better look at each one. Alright, so looking at our first choice A, let's see if it has what we're looking for. Alright, well as I go along I see right from the beginning we have a point here and we have a point here, and they're both at the same place on this x-axis, right? And I'm not really, I could label this just for helpfulness, I'll label that x and y. And I don't really need to put the tally marks on this one you could normally see on a graph because it's pretty clear to me that these two have the same x points. Okay? So let's move on to the next one. Oops. There we go. Alright, so we can rule A out. We're going to go on to B. Alright, so what do we have going on with B? Well, again, if I just read from or look at the graph from right to, or from left to right, the very first thing I see, I have this point here, definitely at the same spot on the x-axis. So that is no good. B is also out. Alright, so we can cross out A, cross out B. Let's move on to C. Alright, now looking at C, at first it seems as if we might have what we're looking for, right? We have this point and there's no point that is on the same part of the x-axis. So if I drew a line down here, you see how we only have one point. But the second we start moving a little bit more to the right, say at this line right here, you can see again we're going to have these 2 points, same x value. That's no good. Alright, so we can rule out C. Let's move on to D. Alright, now D, it goes a little bit more to the left than the other graphs, but that's not really a problem. That doesn't violate what we're looking for. So let's just draw some lines on D to see if it ever makes that mistake that the other 3 have made. Well, from the very first point, it's looking alright. You see how there's nothing else directly vertical above or below it, right? No other points there. And as we keep going, I'm really not seeing a whole lot of instances. Now this point right here, it does look like because these 2 lines connect right here. However, this is just one point on the graph and there's nothing directly above or below it, so nothing else is going to share its x-coordinate. Alright, makes sense. We keep going. So D is looking pretty good right now. D looks like a strong choice. But let's just check out E to make sure we didn't mess up somehow, because that could happen. Alright, and E, just like A and B, I believe, right from the get-go, we have this line here, this vertical line. That's not going to work out. 2 points of the same x-coordinate right here, so that's no good. We can cross out E, and I think we can confidently say that D is the correct choice for this problem. The only one that follows our statement, no 2 points on the graph have the same x-coordinate. So answer for number 4 is D. Alright, moving on. Okay, number 5. This again is a word problem. Again, we're just going to break it down, figure out what it wants from us, figure out what information the question is giving us. Alright, the Venn diagram above, or I suppose to the right in this case, the Venn diagram to the right shows the distribution of 30 science students. Alright, so how many students are we dealing with total? Just told us right there. We have 30 students who studied butterflies, grasshoppers, both, or neither. So right here, all this statement is it's explaining what exactly the Venn diagram is telling us. So let's just keep track of things. Okay, who studied butterflies. And now this means that there's kids that only studied butterflies. So if we look at this graph over here, we have kids who study butterflies and kids who study both butterflies and grasshoppers. Something that's tricky about Venn diagrams, they could show you, alright, the total number of kids who studied Venn diagrams is actually 12, right? And 3 of them studied both. Right here, though, this number is indicating this is the number of only butterflies, not the number of total kids who studied butterflies. So I'll just give it a little shading to show that 9 represents only this part of the Venn diagram, not the total number of kids who studied butterflies. And that's an important distinction to make. So 9 for here. Alright, there's students who studied grasshoppers. Again, the same reason. This 15 isn't the total number of kids who studied grasshoppers, just the total number of kids who only studied grasshoppers and nothing else. Alright, moving on. Both. Alright, and so that's what, now it's telling us what that 3 there means. The 3 is both. So the overlap between these two circles in the Venn diagram, or neither. So there are some kids out there who didn't study butterflies, grasshoppers, or some mix between them. They've made it focused on some other, I don't know, something else that's not as good as a butterfly or grasshopper. Alright, and that's this little 3 right here. I'm not going to shade in the whole box. What percent of students studied butterflies only? Alright, so now that's important. That's the question's actually, I'm going to write down, it wants to know only butterflies. And what color we are using? Blue for butterflies. Gotta scrunch that in. Butterflies only. Alright, so let's look at how many students study butterflies only. I think we already established over here that 9 was our number of butterflies only. Alright, so only butterflies. That was 9. Now is that what it's looking for? It's saying what percent of the students. So I should have made a mark here. We want the percentage of only butterflies. Okay, so how are we going to figure out the percent? Well, for those of you who don't know, the easiest way to do percent, in fact, I think the only way to do percentage is you take the number of kids who study butterflies only, and you're going to divide that by the total number of kids. So the total number of students in this case, I believe it said 30. Yeah, we have 30 students. So it's going to be 9 divided by 30. And at this point you could use your calculator, or you could just do it in your head, and that's going to get us roughly 0.3. And the way we get to percentage is we multiply that by 100%. And that will get us 30%. So there's 30% of these kids that studied only butterflies. And that is choice C right there. Cool. Alright, final problem. Problem number 6, I believe. Okay, in the figure above, AB is equal to CD. Well, let's just take a moment and see what the heck they're talking about here. Alright, so it's giving us 2 line segments. I didn't write this down. This is the y-axis. This is the x-axis. This is just the grid you would see on any graph. However, these two here are actual line segments. Alright, so it's saying we have line segment AB, which I drew in yellow for us. So line segment AB is this whole guy, right? And we have line segment CD, which is in blue. Now, was it telling us about these 2 line segments? It says their lengths, this is what this means, their lengths are equal to each other. So that means if this guy is like 20 or 30, then that means the other one has to be 20 or 30, right? We don't actually know what their lengths are yet, and I'm imagining that's what it's going to want us to find out. What is the value of t? Alright, so where's t appearing? Okay, so t is actually the y-coordinate on b. So b is -2 backward, or -2, or 2 to the left from the origin. And we are not sure how far it goes down from the origin, and we're trying to find that value. Alright, so let's just break this down. So we know that CD is going to be equal to AB, right? And I think we have the length, or we can at least find the length of CD pretty easily. Now you could use distance formula to find the length of this line, but I think because it's just a horizontal line, it'd be easier just to basically count, if you will. So we know we start at -4 and we end at 6, so I think that's going to give us a length of, CD's length is going to be equal to 10, I believe. And an easy way you could just calculate that if you're dealing with not so simple numbers here is you would just take 6, you'd take one of the terms and subtract the other term. So it'd be 6 minus a -4, 6 minus, or that'd end up being 6 plus 4. It's going to get you 10. Alright, so that's important. We now know that CD is equal to 10, and we've already established up here that AB is equal to CD. So if CD is 10, you've probably guessed that means AB is going to have to be 10. That makes sense, yeah? Alright, so now we know AB is 10, so how's that going to help us get T? Well, this AB right here, it's just a completely vertical line. And we start at -2 and we go to -2, so the x coordinate doesn't change at all. So that means this whole thing here, basically the change in the y values has to be equal to 10, right? Because if there was no change in the y values, then this line wouldn't have any length. Okay, so let's think about this. If we start at 3 and we need to, here I'll show it in a number line. Maybe that'll be simpler. Here's 0, 1, 2, 3. Alright, so our starting point is 3. And we need to go a total of 10 over. So that doesn't mean that it's going to be, we're going to get like -10 as our answer. That just means if we count, and that's what I'm going to do. Here, I'll just make some tallies. Alright. That means in the end we should have gone a total of 10. So let's start going. 1, 2, 3, we got to 0. 4, 5, 6, 7, 8, 9, 10. Alright, so we've gone 10. This is where we're going to end. Here, I'll write it down here. This at this white star. And let's see what value that would get us. So if we have 0 right here, this means that's going to be -1, -2, -3, -4, -5, -6, -7. So that means we ended at -7. So going back to this guy right here, if we start at 3, we go down 10, we just established that we have to end at -7. Well, I think that means that t is going to have to be equal to -7. Alright, so I think it's safe to say that our answer is going to be C, -7. And now, one way to see this, again, without having to write out this whole number line, is we do the exact same thing we did here. Although we're not going to be able to fill in what we're going to be able to fill in what the distance is, but not know what the second point is. So if we know we start at 3, and we subtract some number t, and that's going to get us 10, we can just do some simple algebra here. -t is going to be equal to 7, because I subtracted 3 from both sides, and divide both sides by -1, because we can't have that negative on the t. We're going to get t equals -7. And so that's a more algebraic way. You could also do it just by kind of looking at it and reasoning it through in your head. Any way you want is fine. Anyway, the main point is that the answer is C, 7, that is the value of t. Alright, and that will conclude this next part. Tune in again for questions 7, 8, and 9. Thank you.